Good morning, everyone, and good evening to those who have of different time zones with the Philippines. I am pleased to present to you our research titled Phytochemical and In Vitro Antioxidant and Antimicrobial Activity of Indigenous Vegetables of Ilocos, Norte, Philippines. My talk would be focused on the information on indigenous vegetables in Ilocos Norte, objectives of the research, methodology, results, and conclusions. Ilocos Norte, Philippines is rich in indigenous plants that have been long utilized as food. In a survey conducted by Antonio et al., 46 indigenous plants belonging to 26 plant families were documented to continually sustain the food requirements of many Ilocanos. Of the 46 indigenous vegetables, 33 were vegetable species. The most common indigenous vegetables that were used in the different Ilocano dishes are the following. One is the Brocchonesia rhizonica, Champerea maniliana, Momordica cochinchinensis, Dioscorea esculenta subspecies spinosa, Poikilos spermum suavilens, Solanum pimpinellifolium, Tetrastigma harmandii, and Telosma procumbens. Like any other vegetables, indigenous vegetables are a good source of natural antioxidants. That is why high consumption of vegetables have been observed to be inversely associated with the occurrence of chronic diseases, and this could be ascribed to the vitamins and phytochemicals of the vegetables. Since the indigenous vegetables are generally prepared as boiled or cooked, cooking was believed to decrease the phytoconstituents affecting the vegetable's antioxidant properties and other biological activities. Hence, this research was done primarily to conduct phytochemical and in vitro antioxidant and antimicrobial activities in indigenous vegetables in varied preparation methods such as raw, boiled, steamed, and dried. Specifically, the researchers aimed to quantify the concentration of flavonoids and phenols from the indigenous vegetables' crude extracts, evaluate the DPPH radical scavenging and antimicrobial activity of the crude extracts, and determine the correlation relationships of the phytochemical constituents with regards to the DPPH radical scavenging activity of the plants. To attain the objectives, we collected the plant samples at the Mariano Marcos State University Indigenous Food Plants Botanical Garden. Then processed the samples, dividing them into 4 portions. One is the raw, steamed, boiled, and dried. Each of the treatments was homogenized in an osteorizer and macerated in ethanol. Then after 72 hours, the samples were filtered and evaporated in rotary evaporator. The crude extracts were then used for the following test. Based on the results of the quantification of phenols, Poikiloispermum suavilens leaf tops have significantly yielded the highest phenolic concentrations among the raw with 273.97 microgram per ml and among the boiled with 188.52 microgram per ml and among the dried with 423.49 microgram per ml. While Tetrastigma harmandii leaf tops had the highest phenolic content among the steamed vegetables with 149.66 microgram per ml. The lowest phenolic content was yielded from the raw, boiled, and steamed tuber of Dioscorea esculenta subspecies spinosa, followed by the dried Momordica cochinchinensis young fruits. In terms of flavonoid content, the highest concentration was yielded from the leaf tops of Champerea maniliana among the raw and boiled extracts, young fruits Momordica cochinchinensis at 61.47 microgram per ml among the steamed, and leaf tops of Tetrastigma harmandii at 164.76 microgram per ml among the dried extracts. Low flavonoid content was obtained from all preparation of Dioscorea esculenta tuber with a concentration of 3.44 microgram per ml in raw, 4.89 microgram per ml in boiled, 0 in steamed, and 4.06 microgram per ml in dried extracts. In terms of antioxidant activity of the indigenous vegetables, 6 to 7 species showed relatively high antioxidant activity or antioxidant activity that is above 50%. Among the raw extracts, Poikilosporum suaveolens leaf tops significantly exhibited the highest antioxidant activity of 90.11%. This was followed by the BRAC samples with an activity of 89.96%. Low activity was shown by Dioscorea esculenta tuber at 19.17% and by Solanum pimpinellifolium at 45.49%. For the boiled samples, Momordica cochinchинensis was the highest at 88.81%, followed by Brucionesia luzonica at 87.94%. Then the least activity was exhibited by the Dioscorea esculenta subspecies Espinosa tuber at 36.19%. In steamed samples, Brucionesia luzonica showed promising activity at 91.49%, followed by Champerea maniliani leaf tops at 90.37%. The least antioxidant activity was again observed in Dioscorea esculenta subspecies Espinosa tubers at 30%. For the dried samples, 3 samples showed promising activity. One was Poikilosporum suaveolens brax with an activity of 93.19%, which is about 0.55% higher than the activity of the ascorbic acid. Next was leaf tops from the same species having 91.43% activity, followed by the Telosma procumbens at 90.89%. This time, Dioscorea esculenta tubers were no longer the lowest because it showed 71.43% activity. Tetrastigma harmandii and Momordica conchinchинensis young fruit showed the lowest antioxidant activity of 17.91% and 22.72% respectively. The half maximal inhibitor concentrations of the antioxidant activity of the 8 vegetables in various preparation treatments was also computed to evaluate their potency in DPPH radical scavenging. A low concentration value would mean high potency on antioxidant activity, and we could already glean on the graph which among the plants have potent antioxidant activity. A correlational analysis was also done, and we found that there is no relationship between the phenolic and flavonoid content concentration of the indigenous vegetables on the antioxidant activity. Finally, the antimicrobial test showed that the dried Champerea maniliana showed mild activity against Staphylococcus aureus and Micrococcus luteus, while the steam samples was highly active against Staphylococcus aureus. With all the results observed, the following conclusions were drawn. First is that the indigenous vegetables tested are potential antioxidants that may boost the immune system to fight diseases. Second is that the richness of polyphenolic compounds in the indigenous vegetables tested may offer other possible health benefits. Drying, boiling, and steaming may significantly increase or decrease the phenolic, flavonoid, and antioxidant activity depending on the plant species. Correlation studies showed that antioxidant activity may not be ascribed mainly to the concentration of flavonoid and phenol content. That's all for now, and thank you for listening.
Thank you very much.